Unit 2 Chemistry, Chapter 18, Part 3. Our final way of analysing salts in water is by UV visible spectroscopy. It's similar to AAS, both in terms of principles and in terms of analysis. So essentially, we measure the light absorbed by a sample, but now we're using it for coloured solutions and solutions that absorb UV light. Okay, so our light source that we're giving out is either ultraviolet or visible light. So we have a light source and we have a slit that we use to make sure we just have one narrow beam of light. We send that through a wavelength selector because again we just want one wavelength of light. Using lots of different wavelengths just gets confusing. And we pass it through our sample, which is now a solution for UV vis, and we detect how much light is absorbed. Okay. We can use it to find out what's present because each substance is going to have a unique set of wavelengths that they absorb, and we can therefore compare it to see what it is. Okay, so if we put something in, we might find that as we increase the wavelength here, we're getting more and more absorption, and then we drop down and we get very little absorption, and then it increases again. Okay, this obviously is reflective of what colour it is because the wavelength that it doesn't absorb, it reflects. So that's what's going to bounce back into your eyes, and that's the colour solution that you would see. What we use it for most often is to find the concentration in the sample. And this is the same idea as AAS. So we start by making a range of standards where we know the concentration, and we measure how much light they absorb. Then, using the same wavelength, we put our substance in which we've got an unknown concentration in, and we measure that absorbance. And we read off a calibration curve to find it. Okay, so we would have, these would be the concentrations of our standards that we plotted against their absorbance. And again, we could read off, if this is the absorbance of our node, read off our graph, read down, and find here, for instance, we've got a concentration around about 3.5 parts per million. This is useful to look at substances in body fluids. It's also useful if you're looking in plastics and polymers to find what sort of concentration of dyes we've got, if they're coloured. And it's very useful in biochemistry to look at DNA and proteins to find out what concentrations of them you've got in different cells within the body.